Astronomy is the study of everything in the universe beyond Earth's atmosphere. That includes objects we can see with our naked eyes, like the sun, the moon, the planets, and the stars. It also includes objects we can only see with telescopes or other instruments, like faraway galaxies and tiny particles. The baffling cosmic questions of the day have always inspired big ideas to answer them. They have stimulated curious and creative minds for millennia, resulting in pioneering advances in philosophy, mathematics, technology, and observation techniques. Just when one fresh breakthrough seems to explain gravitational waves, another discovery throws up a new conundrum. For all we have learned about the universe's familiar constituents, as seen through telescopes and detectors of various kinds, one of our biggest discoveries is what we do not understand at all. More than 95% of the substance of the universe is in the form of dark matter and dark energy. In many of the world's most populated areas today, many of us are barely aware of the night sky. We cannot see it because the blaze of artificial lighting overwhelms the faint and delicate light of the stars. Light pollution on this scale has exploded since the mid-20th century. In past times, the starry patterns of the sky, the phases of the moon, and the meanderings of the planets were a familiar part of daily experience and a perpetual source of wonder. Few people fail to be moved the first time they experience a clear sky on a truly dark night, in which the magnificent sweep of the Milky Way arches across the sky. Our ancestors were driven by a mixture of curiosity and awe in their search for order and meaning in the great vault of the sky above their heads. The mystery and grandeur of the heavens were explained by the spiritual and divine. At the same time, however, the orderliness and predictability of repetitive cycles had vital practical applications in marking the passage of time. Archaeology provides abundant evidence that, even in prehistoric times, astronomical phenomena were a cultural resource for societies around the world. Where there is no written record, we can only speculate as to the knowledge and beliefs early societies held. The oldest astronomical records to survive in written form come from Mesopotamia, the region that was between and around the valleys of the Tigris and Euphrates rivers, in present-day Iraq and neighboring countries. Clay tablets inscribed with astronomical information date back to about 1600 BCE. Some of their constellations we know today have come from Mesopotamian mythology going back even earlier, to before 2000 BC. The systematic astronomical observations once used for astrology started to become increasingly important as a means of both timekeeping and navigation. Countries had highly practical reasons, civil, as well as military, to establish national observatories, as the world industrialized and international trade grew. For many centuries, only astronomers had the skills and equipment to preside over the world's timekeeping. This remained the case until the development of atomic clocks in the mid-20th century. Human society regulates itself around three natural astronomical clocks: Earth's rotation, detectable by the apparent daily march of the stars around the celestial sphere to give us the day, the time our planet takes to make a circuit around the sun, otherwise known as a year, and the monthly cycle of the moon's phases. The combined motion in space of Earth, the sun, and the moon also determines the timing and magnitudes of the oceanic tides, which are of crucial importance to coastal communities and seafarers. Astronomy played an equally important role in navigation, the stars acting as a framework of reference points visible from anywhere at sea. In 1675, British King Charles II commissioned an observatory, the Royal Observatory at Greenwich, near London. The instruction to its director, the first Astronomer Royal, John Flamsteed, was to apply himself diligently to making the observations needed for the perfecting of the art of navigation. The practical reasons for pursuing astronomy and space science may have changed, but they still exist. For example, Astronomy is needed to assess the risks our planet faces from space. Nothing illustrated Earth's apparent fragility more powerfully than the iconic images, such as Earthrise and Blue Marble, taken from space by Apollo astronauts in the 1960s. These images reminded us that Earth is a small planet adrift in space. As surface inhabitants, the protection afforded by the atmosphere and Earth's magnetic field may make us feel secure, but in reality we are at the mercy of a harsh space environment, blasted by energetic particles and radiation, and at risk of colliding with rocks. The more we know about that environment, the better equipped we are to deal with the potential threats it presents. There is another very important reason for doing astronomy. The universe is a vast laboratory in which to explore the fundamental nature of matter, and of time and space. The unimaginably grand scales of time, size, and distance, and the extremes of density, pressure, and temperature go far beyond the conditions we can readily simulate on Earth. It would be impossible to test the predicted properties of a black hole or watch what happens when a star explodes in an Earth-bound experiment. Astronomical observations have spectacularly confirmed the predictions of Albert Einstein's general theory of relativity. As Einstein himself pointed out, his theory explained apparent anomalies in Mercury's orbit, where Newton's theory of gravity failed. In 1919, Arthur Eddington took advantage of a total solar eclipse to observe how the paths of starlight deviated from a straight line when the light passed through the gravitational field of the Sun, just as relativity predicted. Then, in 1979, the first example of a gravitational lens was identified, when the image of a quasar was seen to be doubled due to the presence of a galaxy along the line of sight, again as relativity had predicted. The most recent triumphant justification of Einstein's theory came in 2015 with the first detection of gravitational waves, which are ripples in the fabric of space-time, generated by the merging of two black holes. One of the main methods scientists use to test ideas and search for new phenomena is to design experiments and carry them out in controlled laboratory conditions. For the most part, however, with the exception of the solar system, which is close enough for experiments to be carried out by robots, astronomers have to settle for a role as passive collectors of the radiation and elementary particles that happen to arrive on Earth. The key skill astronomers have mastered is that of making informed choices about what, how, and when to observe. For instance, it was through the gathering and analysis of telescopic data that the rotation of galaxies could be measured. This, in turn, quite unexpectedly led to the discovery that invisible dark matter must exist. In this way, astronomy's contribution to fundamental physics has been immense. Up to the 19th century, astronomers could only chart the positions and movements of heavenly bodies. This led the French philosopher Auguste Comte to state in 1842 that it would never be possible to determine the compositions of planets or stars. Then, some 2 decades later, new techniques for the spectrum analysis of light began to open up the possibility of investigating the physical nature of stars and planets. A new word was invented to distinguish this new field from traditional astronomy: astrophysics. Astrophysics became just one of many specialisms in the study of the universe in the 20th century. Astrochemistry and astrobiology are more recent branches. They join cosmology, the study of the origin and evolution of the universe as a whole, and celestial mechanics, which is the branch of astronomy concerned with the movement of bodies, especially in the solar system. The term planetary science encompasses every aspect of the study of planets, including Earth. Solar physics is another important discipline. With the spawning of so many branches of inquiry connected with everything in space, including Earth as a planet. The meaning of the word astronomy has evolved once again to become the collective name encompassing the whole of the study of the universe. However, one closely related subject does not come under astronomy: space science. This is the combination of technology and practical applications that blossomed with the establishment of the space age in the mid-20th century. Every space telescope and mission to explore the worlds of the solar system makes use of space science, so sometimes it is hard to separate it from astronomy. This is just one example of how developments in other fields, especially technology and mathematics, have been crucial in propelling astronomy forward. Astronomers were quick to take advantage of the invention of telescopes, photography, novel ways of detecting radiation, and digital computing and data handling, to mention but a few technological advances. Astronomy is the epitome of big science, a large-scale scientific collaboration. Understanding our place in the universe goes to the heart of our understanding of ourselves, the formation of Earth as a life-supporting planet, the creation of the chemical building blocks from which the solar system formed, and the origin of the universe as a whole. Astronomy is the means by which we tackle these big ideas.